Hey everyone, and welcome to another episode of CNC Basecamp. Got a fun project for you today that I think you're going to like. All of us love building boxes. You know, there's something fun. It's small, it's a great gift, it's a super woodworking project. So I thought today what we would do is look at how we can take a simple box and make it really special. Special by using metal inlay. Now, if you're a fan of the arts and crafts movement, no doubt you've seen some of the beautiful inlay work. Nickel, silver, bronze, and copper are wonderful metals that you can make inlays with. Use our box, make your own. I hope you'll enjoy the patterns and give metal inlay a try with your CNC machine. This episode is sponsored by Inventables. Design it, build it, sell it. Learn more at inventables.com. What I've got here are 3 samples of metal that you can cut on your CNC machine that work great for decorative work. Here I have copper, which of course has that wonderful reddish glow to it. This is bronze. So bronze is copper with tin added to it. And it's more of a gold sheen. Finally, I have nickel silver. Nickel silver is copper, tin, and zinc. The nickel gives it that wonderful silver cast, and when polished, it's bright, really appealing. So these 3 metals give you a nice palette to work with for metal inlay on all sorts of projects. Each of these pieces of metal that you see here is 20 gauge. 20 gauge is equivalent to approximately 1/32 of an inch, and that's a nice thickness to work with. It's not too flimsy where you're going to bend it and damage it, but it's not so heavy and thick that the machine can't handle cutting through it. So 20 gauge works pretty well. You might consider going a little bit lighter. You could say do 22. 24, I don't think I'd do any thinner than that. So this really works very, very well. So now let's take a look at today's project. So as you can see on the screen here, I've got a small lidded box. The box itself is nothing special. 4 sides, they are box jointed together, and the lid lifts off. As you can see, I've added a cloud lift pattern to the box and to the edge of the lid. One reason for doing that, aside from decoration, is that the box lid is essentially self-centering on the box itself. There's no hinges, and I don't have to put liner strips or some kind of a rim inside to get the top to engage and center on the box. It happens automatically. And so it's a nice little trick if you're not wanting to use hinges or liner strips to simply use a pattern on the sides. What you do have to do though is make sure that when you come off from the corner, you're coming off perpendicular to that corner. If you have a curve or an angle, then the different parts of the box are not going to come together seamlessly at that corner. So it does have to be perpendicular, and that's what I've done here. So it's a nice, easy way to create a lidded box. Here, of course, is our panel for the box lid. And you can see here, this is the metal inlay. This pattern is 2 oak leaves. Very attractive. If you're arts and crafts fans, very appropriate. So let's take a look at our 2 other patterns. This box has a stylized flower. It's a little bit Art Deco, a little bit arts and crafts. For this flower, my plan would be to use copper for the leaves and nickel silver for the flower petals. Moving along to our 3rd pattern, here's something fun, ginkgo leaves. This, I think, should be done all in copper. So oak leaves in bronze, ginkgo will be copper, and our flower will be nickel silver and copper as well. So that's 3 designs for you to choose from for a box. So let's go ahead and get started and deal with how we're going to go ahead and prepare the metal for cutting and start cutting the pattern for the oak leaves. Our first step in getting ready to cut the metal inlay is to think about how we're going to hold the metal securely while the router cuts it out. You know, it's always a challenge with a CNC machine, isn't it? we have to secure our parts down to the bed of the machine. Sometimes we use hold downs, double-sided tape, hot melt glue. There's all sorts of different ways. But thin metal is a particular challenge because the parts of our cutout, the router bit wants to pull the material up, and any kind of vibration or rattling or movement can result in a very ragged edge, a damaged part, and a broken bit, particularly with the small sizes of bits that we're going to be using. So, how do we go about adhering a piece of metal securely and being able to get our part off without damaging it? Well, I found a pretty good way to do that, and it's using hide glue. The nice thing about hide glue is that it's water soluble. So what we're going to do is actually glue the metal down to a substrate, allow it to dry, machine our part, throw it in a bucket of water, and let the glue dissolve, and our part will come off without any damage whatsoever. So how do we start? Well, I've got a little Scotch-Brite pad here, and the first step is that I want to rough up the back of my metal. I want to give it a little bit of tooth so that the glue has something to grip. With that done, I'll simply apply a very thin coat of hide glue. You don't get any prizes for glue squirting out the sides of this when we clamp it up. All that does is going to make a mess. We need a very thin coat, evenly applied, that covers all the surfaces. And there we go. So I'm going to let that dry for about 24 hours. It'll be ready to cut. Well, I'm starting to get things set up for cutting the copper. First off, let's look at the business end that's going to do the work for us. This is a 1/16 inch router bit. It's got two flutes. It's an upcut. These are really wonderful bits for cutting this inlay material. Now, when you buy a 1/16 inch router bit, one thing you want to do is to make sure you get the shortest cutting length possible. So this is a fairly short bit. A long bit is going to tend to flex and has more likelihood of breaking than a shorter bit. So, shorter bits. I also am using a precision aftermarket chuck in my router here. These are highly recommended. The collet has many different segments in it rather than just 2 or 3 like the standard collets do. And it really is much easier to use. Also, you have to be very vigilant about keeping these collets clean. So, precision collet, a clean collet, and it simply gives us a rotation that has less wobble to it, and that's a bit saver. Also, you're going to see me using a little bit of this. It is an aerosol cutting fluid, specifically for machining operations. The RPM for our router bit is going to be around 19 to 20,000 RPM. For these small bits, we want to turn a little bit faster than we would with other router bits. I've got it loaded in Mach 3, which is the control program that I'm using for the Woodsmith CNC router. And if I see the chips build up in the kerf lines, I am going to blow those out with just a quick puff of compressed air. When using compressed air, we need to be super careful not to blow chips everywhere, so I'll have the pressure turned down to about 20 pounds. Well, here's our completed oak leaf inlay. Now, as you can see, I made 2 of them. One for our project today, one for a gift for home. I'll take it off the table now, throw it in a bucket of warm water, and in about 24 hours, the hide glue will release, and we'll have 2 nicely cut copper oak leaf inlays. Well, we have our copper oak leaves cut, so it's time to move on to making the panel in which the oak leaves will fit into. So I'm going to use walnut because it's got a really nice contrast to the copper. I still have that 16th inch bit in the router, and that 16th inch bit will create the relief for the copper. Once we're done cutting the relief, I'm going to change bits. I'm going to put a 1/4 inch upcut bit in the machine. And with that, We'll cut the perimeter and cut our panel free. Well, there's the completed panel for our inlay. Of course, we have the relief for the oak leaves. There's also an 1/8 inch tab running all the way around the base of this panel, and that's going to engage the sides of the box and allow this panel to float. Also, note that there are 4 tabs that I've used to keep my parts centered within the motherboard as the bit cuts through. I'll knock those out with a chisel, sand the edges, we'll be ready to proceed with the inlay. Well, I've been working on the sides of our box, but I'm going to take a little break because the leaf inlay separated off the board that I had it glued to. So I've cleaned it up and I want to go ahead and get it mounted and drying while I continue to work on the sides. Now, you can use a lot of different glues to adhere the metal inlay to your wood panel. Hide glue works great, gives you plenty of time. I like that. Another option, which I'm going to use today, is simply some CA, something that doesn't dry too terribly fast. So, no big deal here, but we do want to go make sure that we apply the CA in all the different cavities. And, you know, it doesn't take a lot, folks. Just a little bit is really all we're going to need to adhere this quite well. The copper is a 32nd of an inch thick, so it is fairly stout. So it can easily bridge areas and has some strength. So what I'm going to do is I'm going to use a hammer here and a block, and I want to very gently start to set it in place. Also an acorn tip here, which I'll put in place. You always want to make sure you use a block, because if you just use a hammer, you're going to end up curling the inlay up out of its recess. Once it's in place, I'm going to put a piece of plastic down to prevent glue from adhering my top clamping caul. And I'm going to go ahead and put some clamps on here. I want to make sure I've got good firm pressure as that glue sets up. And there we go. So I'm going to set that aside and get back to my box. I have 3 of the sides already cut for our box, and I'm getting ready to cut the last side. From this piece of wood, we'll get both a bottom side of the box and a side for our lid. You can see here there's a slight groove, and that groove is for some clearance to help our joints fit together tightly, because we're having to address the issue of that filleted cut that a router always leaves. Here is our plow for the 1/4 inch bottom of our box, the plow that will hold the lid with the inlay, and of course our router is going to cut all of those finger joints as well. So let's go ahead and fire things up, and we'll cut our last side and our last side of the top. I've got all the sides cut for the lower part of the box and for the lid. Now what we need to do is prepare the joints so they'll fit tightly together. Let me show you an example. So if you look at this sample here, you can see that I've taken a round over bit and I've rounded over the inside edges of all these fingers. I've done that so that they'll fit tightly into the mating slot, because the router, of course, can't cut a 90-degree angle down in here. So each of these has a fillet. And all I'm doing is putting a mating fillet on the other edge of the finger so we get a nice, tight, clean box joint. What I have set up here on our router table is a 1/16 inch radius solid pilot bit. And I've got the fence set up because I don't want the bit to go all the way down to the root of our box joint here, because that will show on the interior of our box. I just want it to clear and come into this channel that we cut earlier. So once I get started here, you'll get the idea. Well, we've got everything cut out. Our box sides, the sides to our top, we've got the inlay finished up. It is time to glue things up. So I've got our box dry assembled here. And I'm going to start by gluing up the bottom. All right, I think that's got our bottom. Bit of a nest of clamps there, but we have a lot of clamps here in the Woodsmith workshop, so I intend to use them. Let's move on and glue up the top. All right, I think that has it. So now we wait for the glue to dry, and when that's done, I'll get everything nicely fitted, nicely sanded, and also work on this top a little bit to bring out the beauty of that copper for the oak leaves. Well, as you can see here, we have a finished box. The lid indexes on the box very nicely, so we have a box made without hinges and without having to go to the trouble of a liner on the interior for the lid to register on. You can see here we have our box joints made on our CNC machine. The only additional item you'll need is a 1/16 inch solid pilot router bit. We have our inlay made with a 1/16 inch router bit on our CNC. And this, of course, is our oak leaf pattern, but let me show you the other two patterns. This is the ginkgo leaf. And here is our Art Deco flower. And that is nickel, silver, and copper, and this is bronze. So nickel, silver, bronze, and copper are wonderful metals that you can make inlays with. Now, all three patterns and the plans for the box will be available on the website along with the complete instructions and a companion article. So, use our box, make your own. I hope you'll enjoy the patterns and give metal inlay a try with your CNC machine. Well, I've just finished completing a number of inlaid box lids for episode 6 of Basecamp. And with these inlays, I was using a 1/16 and sometimes a 1/32 inch router bit. Small bits and a project that required great accuracy. So I thought it'd be a good time to talk a little bit about maintenance on the Woodsmith machine. Some of the items we're going to go over are specific to this machine. Some are going to be applicable to other kit machines or plug-and-play type machines. So let's go over a number of things here that will help ensure accuracy and good performance with your router. First thing, let's begin with a little bit of collet care. So the collet that I have here is a precision collet, which I really recommend as an aftermarket accessory for these 1 horsepower routers. You can see we have a collet nut, a 1/4 inch collet, and a 1/8 inch collet. So very important to keep them very clean. Now, what came with this collet was a bit of collet care cleaner. And one thing I really want to stress when dealing with collets, and I'm sure you've probably read articles in the different woodworking magazines, is being very careful not to score them anyway and being gentle with them. And so we don't want to use any kind of a wire brush. I'm putting the gloves on here because this collet cleaner actually is it's got petroleum distillates, but also has boron in it, and so they recommend that you don't get it on your fingers. It's a little hard to get into this 1/8 inch collet, but I can at least clean the exterior of it and really make sure it's nice and clean. The 1/4 inch, of course, is a little easier to get down in there inside the collet itself. And I want to go around the exterior and make sure everything is nice and clean. If there's any dust trapped within the slots that divide the collet, I need to get that out. And we want to keep it nice and clean. Equally important is that we get up into the router itself, because the dirt really does tend to cake inside the shaft area. You can see my Q-tip here is coming out pretty black. And then we also want to make sure the threads are very clean too. If you feel you need to use a brush, please use something with nylon bristles or brass bristles, but not steel. As soon as we start putting score marks into metal, then that becomes a place where more and more dirt gets trapped. So as you can see from the Q-tip, it was worth cleaning that. The next step in taking care of our Woodsmith CNC router is going to be to clean the aluminum rails. Because they're exposed, we do get a little bit of a buildup of dirt on them over time. Cleaning them is nothing more than taking a soft rag or paper towel and wiping them down. And as you can see, I'm picking up a little bit of dirt off of them. I want to go ahead and wipe down both rails of the y-axis, both rails of the x-axis, and the z-axis as well. Now, as you're doing this, you can kind of do half at a time, and then you'll need to move the gantry about to access the balance of the rail. So the paper towel gets most of the grit off. To finish things up, I find it useful to use a little bit of solvent. You don't want to use much, but it does help get things nice and clean. One thing I want to stress here with these aluminum rails is please don't use anything abrasive like a Scotch-Brite on them. As with the collet, when we scratch the surface of the metal, all it does is provide a perfect place for more dirt and debris to lodge. So keep things smooth, keep them polished, and don't use anything abrasive on them. So I'll move the gantry back, clean the other side with the solvent, and then go through all the different rails and make sure they're clean. When that's done, then we move on to the V-bearings. Well, now that our rails are clean, it's time to move on to the V-bearings. Pretty simple. What we want to do is use a small brush like this, or an old toothbrush would be great too, and just gently knock all of the debris out of the bearing. Once you get as much as you can, you'll need to move your gantry and have the bearings rotate slightly so that you're cleaning all the way around them. Well, next up in our CNC maintenance program is going to be to make sure that the V-bearings are tightly engaged with the rails. And what we're doing there is we're essentially preloading each of the carriages on each of the axes. So we preload the bearings on the x-axis, on the y-axis, and on the z. And by putting everything under tension, under pressure actually in this case, we're going to make sure that we don't have backlash and any rattling. It's all going to be solid, firm, smooth action, and that's going to give you accuracy. With this machine, each carriage has 2 fixed bearings and 2 bearings in opposition to those which are adjustable. So this is an example of this bearing and this bearing. You can see I've got a handle to rotate here on the front. I've got a 1-inch dowel, and the hole for this bolt that goes all the way through is offset. So I don't know if you can see it. I'm going to rotate this slightly. You can see that the bearing and washer package on the end is offset. And so it has a cam action. When I loosen the bolt that goes through this cam, I can then rotate it and set a tension or a pressure upon the rail. I'll do that. I'm just taking a pair of wrenches, loosening the nut, and then I can actually rotate and put a nice solid tension on the bearing. Now we don't want it too tight. Having it too tight will cause excessive and premature wear, but we want it nice and snug so that our carriage has no movement to it whatsoever. This is an important thing to check before any project which demands absolute precision. The simplest way to do it is just take your fingers and feel if you can rotate any of these bearings. You shouldn't really be able to. They should be firmly applied to the rail, and they should be difficult to move with just your fingers. So if you check that, that'll keep things accurate and you'll be happy with the performance of your machine. Another mechanical element that we need to care for on our CNC router are the lead screws. So there's a lead screw for the Z axis, there's a lead screw for the Y axis, and then running underneath the machine is a lead screw for the X axis. Now, as with our other components, we want to take a little time to make sure that they're clean with a soft brush. You'll probably need to move things several times to get them to rotate. Once you've got all the dust off of the lead screws and they're clean, we want to apply a dry lubricant to them. It's important that we don't use oils because they'll attract more dirt. There are a lot of different kinds of dry lubricants. This one happens to be Teflon based. So what I'm going to do is just put a small spray along the whole length of my lead screw, and I'll do that for all three of them. Now I know that our X lead screw is a little harder to get to, so you will need to prop the router up just a little bit, but you don't have to do that often, so not a big deal. With the lead screws lubricated, another thing that we want to check, and this is a long-term maintenance item, is the anti-backlash nuts. The anti-backlash nuts engage the lead screws and are the way that the action of the lead screw is then transmitted to the different carriages. What I have in my hand here is a Delrin anti-backlash nut off a machine very similar to this. So there are 3 anti-backlash nuts in this unit. One for the Z, one for the Y, and then underneath on the gantry, one for the X axis. What we're checking for on these is any excessive wear. So if you look down and you see things that give you some clues, maybe the surfaces look worn, maybe the surfaces look a little rough, it may be time to change these out. I changed the anti-backlash nuts on another unit like this after about 400 hours of operation. The one for the X-axis sees a little more rugged use because of the weight of the gantry than the one on the Z-axis, so that's really the one to start with. You know, anti-backlash nuts are very unique items. What it is a nut that has essentially been split into 3 sections. So think of your collet on your router, and then there's a cage that surrounds it and a metal spring which forces that cage around the collet and keeps it tight. And what that does is it keeps the nut always tight around the lead screw, and it doesn't allow it to rattle. And because it's tight, it can't move, it compensates for wear. That gives us accuracy, and it removes the contingency of backlash, which is the enemy of all machines, especially routers. So once you've checked your anti-backlash nuts, cleaned and lubricated the lead screws, that completes the maintenance for your Woodsmith CNC router. All right, well, we've completed the primary tasks in taking care of your CNC router. One last thing, do make sure that you go around and check all of the fasteners on this machine. Now, this machine is home built. It's made primarily of Baltic birch plywood, and so it's stable, but it's still wood, and it's going to be subject to some seasonal movement. So it's important that with every swing of the seasons, you do take some time just to tighten everything up. Now, this whole process may seem like a lot of different individual items, but really it only takes about half an hour at most to do everything. So it's pretty easy. How often should you go through all this? Well, I think dealing with the collet care, cleaning the rails, cleaning the bearings, that's maybe a 4-time-a-year activity, depending on how often you use your machine. Dealing with the lead screws, checking your anti-backlash nuts, that's a yearly activity. Tightening up all the fasteners, as I said, seasonal, let's say twice a year. So it doesn't really take very much care to keep your Woodsmith CNC router in peak condition. This episode is sponsored by Inventables. Design it, build it, sell it. Learn more at inventables.com.